Start. So let's get started. I hope you have safe, stay safe during the weekend where we have very severe weather, which we haven't seen it for 300 years. Okay, but that is a probability statement anyway. If you know what do you mean by a 100-year event, right? It's just there's a model there. Then try to say this is very unlikely. So we will learn that kind of model in the topic 3, where you learn some random variable and learn some distribution. We have a model, and they say it's very unlikely, right? That would be the thing that the government is talking about. So since it has been a week, so let me very quickly go over the thing. But before we go on, is there any question that you want to raise? Oh yeah, I noticed there's some chair is not working. I guess that the weather there's a problem, but I hope things are fine in your seat. So very quickly that let us I don't know. I mean, suppose that someone should be joining in from the Zoom, but anyway, what we have covered in the last time is very briefly to go over the topics of statistics and talk about what we are doing. Quickly is like there are 2 parts of statistics. If you try to recall, would be one is called descriptive, and the other is called inferential. Descriptive means the way that you have a data, you try to summarize what you have from data, right? So it's not you try to extract information there. Okay, it's not getting you any new knowledge except from discovering from the data. And inference is the idea that you try to get new thing from what the data have. The idea is that the data what you have is one instance or one part of the thing you want to study, right? The sampling, right? You want to study the big thing, but you will try to get the small stuff, right? Just like all the business case, right? You're never able to get information for everyone, but you try to do some marketing, right? Just try to target some group of people, and you try to get some conclusion or the pattern you learn from this small sample and try to see if it holds for the big, and how do you bridge the gap between the two, right? And that rely on probability. That is, we will learn after this chapter. Probably will be next week. Okay. So in this week we'll finish this topic. So just to remind you quickly, the data we are working on. There are many types of data, and we will focus on the continuous type in our class. Although our tools would work fine with discrete, but if you want to do seriously for discrete data, you need a much advanced tool. Similarly for the ordinal or nominal. Okay, I mean the type we have continuous looks the most complicated one, right, in terms of the structure, but indeed the math you use is much easier. Okay, so that's why we focus on the easiest thing, and for business application should be fine, right? Most of the thing talk about is money, right, or B school, so shouldn't be an issue. But just bear in your mind that we're looking at continuous data, all right? And this is the only slide, probably a few more as well, but this is the only slide we are talking about graphics. And as I mentioned last class, some of you may not be here, the graphics for our business application indeed is the most important thing that when you write a report or present your result, that is what the visual part or the colorful part that catch people's attention, of course, beside tables, but how to have a good graphics, right, would be something you have learned since your kindergarten, right? You use the color pen and draw things, right? So you should be able to do it. I mean, it's not my class able to teach you how to do different arts, different coloring, different font size, so on and so forth, right? I mean, but you should be able to handle that by yourself, right? And I would say, although we teach Excel in the class, and I would say the Excel graph so far is not very satisfactory, right? But I mean, we just keep it. But as we know, I mean, Python will be soon adopted in Excel probably next year. Okay. Unfortunately, we're taking class this year, so we're still using old technology. But you should update yourself because now the working environment is pretty competitive. So if you are one step behind, then you're forever behind. But anyway, so there are three things that we want to talk about beside the visual one is the numerical representation. And these are the three aspects that we cover. And we should be able to cover all these three in this class. We will left the correlation and the Excel for the next class. So Friday, we will basically cover the topic one fully. Okay. So just very quickly remind you what is central tendency, right? It's a one number that try to summarize what we have, right? If you try to ask you what data is about, there's a question from the boss, then you would tell them mean, median, mode, one of them, or three of them, depends on the data, right? And then the next question would be the boss would ask, okay, how good is your number, right? Then you would give this person, right? It's how spread the data, right? You remember the range, right? The IQR, we didn't go into big detail, but today we'll talk about the IQR. And we'll importantly talk about the variance or standard deviation, which is you always listen to when you try to hear people talk about statistics, right? That's the main thing that you learn from this class, and probably there's something you stick in your mind forever is the mean and variance or mean and standard deviation. That's the thing that we'll be doing all the time. And of course, some of you have learned in the high school that already in your mind already. So what is new, at least from this class, is we talk about shapes, and their measure later you see is very similar to variance, talking about skewness and kurtosis. And they will tell you how the shape of the data looks like. Is it symmetric or not? Okay. And the last one, talk about kurtosis, is talking about how thick, how extreme the values are. And you probably ask why we care about these two numbers. First, later you will see these are important metrics to say whether the classical approach we adopt in this class work or not. Okay, because of introductory class, so we can't tell too much about advanced thing, but we'll tell you that there's a bells and whistles here that you might have to be careful, right? And if the bell rings, then you probably need to look at more advanced textbook. And also people nowadays care about how skewed the things are and how fixed the thing are, right? Probably many of us may not have seen a typhoon signal number 10, right? Or number 9, right? But these days are becoming more frequent, right? Why? Because the world, people say global warming, right? Global warming, what does that mean, right? Will be a lot of extreme thing happen, right? That is the kurtosis that matters, right? Or then the financial market, right? We see a lot of extreme things happen, right? And the world is different because of kurtosis. And you fail to acknowledge the kurtosis or the thick tail, the extreme values, that will make disaster, like the financial crisis in 2007-8, right? Then one of the people will tell you why things happen, right? Because the financial engineer, not the quantitative finance classmate here, but those people who are doing that time is all the engineer from physics and mathematics. And they look mean and variance, they fail to take into account of the kurtosis, and the model fails, and you know what happened, right? For skewness, right, the same idea, right? And then we know a lot of time when the thing is skewed, then the usual tool we use have to be very careful. So if you want to know what happened, you look at data, you see this kind of thing doesn't work out very nicely your data, then you have to consult a more advanced textbook. But we just trying to say most of the time these things will work, and we focus on the thing we work on these simple data. But if you're more advanced, then it's not our job to do it, right? Probably you'll be like if you have to go to stat department and or go to master program and can learn it. I mean, it's not done in the undergraduate level. Okay, at least not BP school, as far as I understand. So very quickly, because we covered it, I just very quickly go over the mean, median, and mode, just very quickly. So I'm not going to go over everything, but just to remind you, the mean is the sum of the observations over n, total number of them. To remind you, there are several things here. Is adding have to be meaningful, right? If n is not meaningful, then you cannot add. And the second thing is you divide by n. The division have to be meaningful. Probably I didn't mention this enough last time. Is your data we assume now is very nice in your assignment or what, but when you do the project, there's a problem. What about missing data? Right? You do a survey, some people miss it, right? Just suppose the survey asks you to rank canteen in CHK, right? And I guess none of you go to every single canteen in CHK, right? And nevertheless, you have missed it, right? Suppose you are going to ask them to rank 1 to 5, right? Then some of you have NA, not the New Asia, but it's not available, the data, right? And then how do you do the average? Right? So you kick out those people, or you assume the average, or what? I mean, the missing have to be handled carefully, right? It's assumed they take the value of 3, or you just omit them from there. If you omit them from there, then n have to change. Okay? So of course, we assume all the data thing is gone. We assume you have a nice data you here, then you handle. But we didn't talk about those. But same, the mean have to calculate, then have to be careful about those. But when you actually work on data, then you will see there's some issue here we didn't have time to mention, but there are a lot of cases, and how you handle the minor detail is, right? It's a difference between a good data scientist or not, right? And attention to detail, right? Just like if you ever write a computer code, right? And it's easy to have the code run, but the code may actually fail and some extreme happen, right? It's the main thing that the computer programmer try to handle those special cases, same as the data scientist, or you are handling data, right? When the data is nice, everything is good, then you know how to do it. But things are not nice, you have to know it, right? I mentioned the kurtosis, skewness, fat tail, skewed data. You have to know how to handle those. But anyway, our class is focused on basics, so it's the basic thing. So the mean is just the middle of the data, just graphically, just like the mean is just located at the location where the left-hand side, the red distance, the same the blue distance. Just to remind you, again, it only makes sense if the distance makes sense. If distance doesn't make sense, then this thing you have to think about whether what you're finding is the right thing. Okay. So just not going to talk about is the outlier. Then what you're going to do is try to trimming and winsorizing. Okay. The missing data I don't put up here because we assume the data come up is very nice already. Okay. And the next thing is median. Median is the middle of the data. Okay. And if exactly middle, then you're done. Right? Suppose it's the 3 numbers, odd number of observations, that's the middle one. Right? But the even number, then there's not clear what's the middle. Right? You have the 2 of the middle, right? You have suppose you have 4 data points for observations, then the middle is 2 and 3. Right? And it will make sense sometimes you just consider average. That is what usually we do. But it might not make sense if data is low, widely spread, then the median may not be meaningful, right? Suppose the data you have is like 1 to 9900, right? Then the median will be 50, but the median is nowhere near anything, right? So the median would be meaningless in that sense. Then probably in that case, the median you should say is like the middle 2 data is 2 and 99, right? But usually the data doesn't have this kind of crazy feature, so that's usually is fine. And usually the mean will be meaningful, so that should be fine. As far as I said, right? We focus ourselves on the continuous data, so this shouldn't be an issue there, right? But because sometimes you report the median is like how many children in the family, right? Then you say 1.5, the median, then what does that mean 1.5? You say 1 kid and then 1 baby or what? It's unclear, right? What do you mean the half of the child? It's not clear what does that mean, right? Say suppose you have to ask how many boyfriend or girlfriend have you ever had? Then you say 4.7. Then what is 0.7? Is it something in the middle? What's 0.7? You don't know, right? And because number of your boyfriend and girlfriend is say discrete data, right? 0.3 and 0.4, I don't know what does that mean, right? But you still use it. You pretend that something is 0.7%, right? I don't know, but that would be something have to bear in mind when you do the average, right? When it's odd, you don't have this problem, right? When you're odd, right? You ask how many noodles have you eaten, right? That would be fine, but that would be things like that, right in the middle. So more as I said, this is the less data restrictive summary statistics, because just trying to ask what's the most frequent data. That means that no matter what kind of data you're thinking in your mind, that would work, because there's no operation there. Just count, right? Just count. I mean, I think the count is the thing that would work for any data. If it doesn't count, then it doesn't work, right? Because it's the thing you do when you were born, right? Just 1, 2, 3. That's the first thing you learn. Beside daddy and mommy, right? But that would be the thing. Now, we know the three representation for the data. Then we have to give accuracy for how those they work and range. I think it's very easy, just the maximum and the minimum, right? And the problem, same as the mean, is like affected by the extreme value outliers. So you probably have to refine a little bit, right? Then the thing that we do is quartiles, okay? Where we just stop, we didn't finish it. Now I slow down a little bit, but is any question? So just to remind you, I speak slower now, I can. So quantile is just divide thing into 4 parts, right? So you do know that graphically, right? It's saying that the range will be the maximum minus the minimum, right? The quantile is saying that essentially, ideally, it's just like the median would cut this into half, right? And the median of the first half will be Q1. Median of the second half will be Q3. IQR is just asking the Q3 minus Q1. So what does that mean? It means that how this tail behavior is not affecting the IQR, right? Because a lot of data, the head and tail can be very weird, depending on what you kind of sample, right? Suppose you do sampling of income data, you do some sampling. Suppose one day you got recasting, right? Then the data will skew. If you don't got, the data will be very different, right? So the idea is like, if you get extreme value, can be very different. So that's why when we look at the IQ, probably you just try to better than the range to measure your thing. Okay. Now you can easily see that the Q2, right, which is a median, we know how to define it, right? It's in the middle of the data, right? But it's rather unclear how you define this Q1 and this Q3, right? Intuitively, right, it's a median of the first half and median of the second half, right? If you have many data, right, then you take the median, would not, the method we're talking about, the free method talking about, would be very similar, right? If data is smooth, then there's no difference. But when you try to, the data you got is not a lot, then it can be a difference. Okay, so what we're trying to do is to give you different definition of Q1 and Q3. Then you have to be careful. So why I'm bothered to give you the 3 definition, just don't give you 1, right? First thing is different people come from different education system, and the ones they learn in the high school, then using different textbook, they're different quantile they learn. So to make sure that if you're on the same page. Second, just how to illustrate that in statistics. If you try to look at Google, now these days so easy, or any search engine, you just look for, say, IQR, you look at Wikipedia, they give you usually not just one measure, multiple measure, right? Actually, we learn from beginning, we learn mean actually have a lot of case, right? Arithmetic mean, geometric mean, harmonic mean, weighted mean, that many things. Quantile is the same, okay? In particular, interquartile range is one thing that at least even Excel have 2 different type of definition. You could R or Python, at least 9 or 10 or even 20 different kind of definition, okay? So, I mean, you would have to use the program someday, right? Then I have to let you know there are different versions. I pick the version I present to you, we use in the class. I'll explain why this makes sense. Of course, one of the reasons I picked this particular one is because it is appear in Excel, also appear in R and Python. So that's why I do that one. Okay. So let me work quickly to go back to remind you what do we have for the quantiles, right? The method and method 2, I think one is used in the UK system, one in the US system. Because you guys are much younger than I do, so I'm not sure the one I learned same as what you do. I think what I learned is method 1, but I'm not sure. Maybe you can tell me during the break is what you learn in your high school. Okay, so Q1 and Q2 is almost the same. Okay, except the fact that Q1 would keep the median into the halves. Method 2 does not. Okay, so work quickly to go to example again, because I think example is always the best thing to understand what the method is. Okay, so we have the data, 5 numbers. Okay, work quickly, and at this point you would immediately notice what the median, right? Because odd number of data, the median exactly middle guy, which is number 3, right? But to be exact, median, just to make sure that you understand the formula, right? N is 5, right? And n plus 1 will be equal to 6, right? The median will be exactly n plus 1 over 2 guy, right? Which is the third guy, right? So x3 in this example is just 3. I make it easier. Okay, so exactly that's why it's 3 here. Okay, make sure you get it right. Now, method 1 would say you would cut the data into 2 halves, right? And median will be included in the halves. Okay, so that means that the first half, right, is 1, 2, 3, right? Because 3 is included into the data. This is the first half of data, 1, 2, 3. And by 3 data, the middle is very obvious, the middle guy, right? Just to repeat the statement, because n is 3 here, 3 plus 1 is 4, 4 divided by 2 is 2, the second data. So it's 2 here. Maybe I use other color to signify this is the, oh, I think I should be a little bit more consistent. Blue is here, and I use red here. The middle guy, right, is the 2, right? And I use green color to notice the second half, right? And second half, you have 3, 4, 5. The middle guy is exactly 4, right? So the Q3 is actually 4, okay? Because 3, 4, 5, right? The middle guy is exactly 4, the median, right? So the IQR will just Q3 minus Q1, which is 2. Is that clear for this one? Is that okay? Is there any question for this one? I think it's very straightforward, okay? The only thing probably I want to say is like, how does it compare to the case where you have method 2, okay? Just remind you that the method 1 and method 2 is the thing I mentioned to connect you to the historical experience if you have ever have the median, so the IQR, but we're not using this anyway, but just let you know what's going on, okay? And in this case, it's the median here. Maybe I should use that other color. The median is 3, okay? And the under method 2, you divide data in 2 parts, which you ignore the median. So this is the first part is 1 and 2. The second half is 4 and 5. Okay, so that's why it's here, 4 and 5 here. 1 and 2 is here, right? The median is just 3. Okay. So for 1 and 2, we have 2 observations, right? And median of 2 number is just exactly the mean of the 2 number, right? It's 2, right? So that's why you got 1.5 here, because 1 plus 2 divided by 2, right? And why you have 4.5 here is 4 plus 5 divided by 2. Okay, just to make sure that you see what I'm doing, right? Half, because median of 2 number, just the just the mean, right? Because it's 1.5, right? So the IQR is just 3. So you can see that the IQR, right, in these two cases can be very different, okay? And if you want to make your analysis transparent, when you mention IQR, you should mention what kind of method you're using, right? If you try to use these two methods, right? And of course, we're not using this method in our analysis. The one we use is what we call interpolation. Okay, we detail it later. But is there any question about method 1 and 2? But because some of you may know 1 or 2, but that's the comparison between the two. And in the case that you can see from the case when you have even number of data, okay, and these two methods will get the same answer. The reason being that, say, suppose the data is 1, 2, 3, 4, 5, 6. Okay, the median is not belong to data. The median is somewhere in the middle, right? It's the middle of 3 and 4. It's 3.5. So it is not in the data, right? So it means that the first half is 1, 2, 3. The second half is 4, 5, 6, right? So then, regardless of method 1 and method 2, you get the same answer. Okay, so that you can see the problem of this approach is really, I mean, when the n is very big, then it shouldn't be a lot of issue. But when n is not so big, then it's a problem. Okay, and the counting is like difficult sometimes. So how do we handle this situation? Okay, and let me use the whiteboard to do it, because I think that will be easiest. Okay, remember Q1, right, is what? Is by definition is 1/4 n plus 1 data, right? Q2 is what? Is half of n plus 1 data, right? And Q3 is what? 3/4 of n plus 1 data, right? Then let's extend the idea of what we do for the median to our case. Okay, median. Okay, what we have been doing for the median, or the Q2, is what we're doing is what, right? n plus 1 over 2. From the math problem, you know, right? It must be, if you convert it to decimal places, right? It's either a whole number or a 0.5, right? It must be 1 or 1.5 or 2, 2.5, so on and so forth, right? It must be multiple of 0.5, right? So what actually we have been doing is, like, suppose what we get is like 3.5, right? We're trying to look at what is the number of x 3.5 there, right? What we have been doing is average of 3 and 4, right? And we're actually thinking in our mind is actually a what we call the linear interpolation. Okay, and what we have been doing is actually talking about this. Is talking about, we start from number 3, okay, and 0.5 is halfway between 3 and 4, right? So that's why we have halfway of 3 and 4. Okay, this is the formula that actually we have been using, right? We start from the smaller number, we go halfway between 3 and 4. So it's actually called interpolation. We call it linear interpolation. Linear interpolation. Okay. And right. So we will extend this formula directly to Q1 or Q3. Okay. So let me extend this idea here, right? This is divided by 4, okay? From your math, 1/4 is a quarter, right? If you change the decimal places, right? It must be, what you get is like 1 or 1.25, 1.5, 1.75, 2, 2.25, so on and so forth, right? Because a quarter, right? 2/4, 3/4, right? And then that's it, right? So that's why when you get the data, it's like x 1.25, say. Okay. Then what you're going to do will be x1 plus 0.25, x2 minus x1, right? So it's getting, you start from x1, the smaller one, and 1/4 of distance between the two, right? And similarly, if you get it's like, say, 3.75, then we're going to do will be x3, right? And 3/4 of x4 minus x3. Is that clear what we're doing? Okay. And actually same for the Q3 as well, because the same thing, right? Because divided by 4, the decimal must be 0.4, 0.25, 0.5, 0.75, right? But anyway, this doesn't have to be anything by quarter, right? If you anything actually will work, right? That's the meaning of percentile. If you learn from the from other occasion, but we don't cover this class. But if you learn percentile, the same idea, right? So you just a linear interpolation there. Okay. Now, of course, don't worry about this math because we'll give example, then you'll work it out. Okay. I just use the whiteboard because I think it's easier to write. Is that okay for this one? Don't worry, we'll give example exactly very clear what's going on. Okay. So let's go to the example. Then you will not be worried about the thing. So the formula mentioned I like is this guy. Okay. I'm pretty sure that this looks a crazy thing to you. Okay. But it's exactly what I'm saying. Okay. The percentile is like percent 2.5 times n plus 1. And you get the integer here, the floor function here, and then you do the same thing. Alpha is the percentage, the decimal places, and you just do here. Okay. But I'm not going to go about this formula because you know what it means already. This is just the mathematical way to say what we have just said. Okay. You just start from the smaller number and plus the decimal part. Okay. But anyway, we'll do it exactly, then you will see what is going on. Okay. So this example is here. What we have is 1, 2, 3, 4, 5. Okay. Now let's go back. Let's forget about this expression and let me use the whiteboard there and show you the formula. Then you will not be too worried about it. Okay. So remember what we have is 1, 2, 3, 4, 5. Okay. This is the 5 number. Okay. What is Q1 here? Q1 is what? Now, first we have to remember to collect the information with the data is n is 5. Okay. N plus 1 is 6. Right. So we have n plus 1 over 4 data point. Right. So it's 6 over 4. Okay. And if you can use calculator, which you allow, right? So it's actually 1.5 data point. Right. 1.5 is very simple, right? What you do is you start from, you're asking what is this number according to interpolation. What you're going to do is you start from the lowest number, just the floor function, right? According to the formula, you just get 1, and you just get the decimal point, 0.5, right? Halfway between 2 and 3, 2 and 1, right? Just to repeat the intuition here. What is x 1.5, right? Is you start from 1, you go halfway between 1 and 2, right? This 0.5 means, right? Half is between 1.5 should be midway between 1 and 2, right? What is midway 1 and 2 is start from 1, half of the distance. Is that clear? So in this example, x1 is the first guy, right? Just 1, right? And half. X2 is just 2 minus 1. So what you get is 1 plus 1/2 is 1/2. Okay. Is that clear how we get the Q1 here? I mean, of course, this is Q1. I should get an equal sign because they are equal. Is that okay? So that is explain what you see in the slide. Okay. And I'm sorry I go a little bit slow for those who are very fast, but just try to make sure everyone is on the same page. Okay. So Q3 is what? Q3 is, according to the definition, is 3/4 n+1 data. Okay. And use the math now. Use your primary school math. 6 times 3 is 18, right? It's 18/4. Okay. And use your mental math, right? What is this? 4.5, right? Right? So my mental math is not very good, but anyway, make sure I'm okay. Okay, I may make a mistake, but here is x 4.5. Okay. What is 4.5? Is basically you start from 4, halfway between 4.5, 4 and 5, right? So we just x4 plus halfway between 4 and 5. Okay. In this example, x4 is the fourth data, which is 4. Okay. And 4 and 5, the fifth data is 5. The data 4 is 4, right? So it's just 4.5. Okay. And that means IQR is just Q3 minus Q1 is 4.5 minus 1.5, which is 3. Okay. So that is the idea behind this one. Okay. Now, if this is okay, I'm going to illustrate another one. Is 1, 2, 3, 4, 5, 6. Okay. And I hope you'll be able to see what's going on. Is there any question before we proceed? I mean, this is, I think in this class is the most complicated thing we cover. Not for this course, but this class, okay? If this course is like this, then probably it's too easy, right? But that would be the case. Okay? Is that clear what we're doing? Okay. And let us repeat to do the same question or similar question, but instead we have 6 number there. Okay. So what we're going to do is first we have to look at what is n here. N is 6, all right? And n plus 1 is 7. Okay. And Q1 is what? Q1 is 1/4 n plus 1 theta. Okay. And we have 7/4, right? And 7/4, if you convert it, is 1 3/4, right? So it's 1.75, right? So just to write it properly, it's just x 1.75, right? This is the notation we're using, right? And 1.75 is what? You start from 1 and 3/4 distance between the two, right? So it's very simple. Is x1 plus 0.75 x2 minus x1. Okay. And that would be x1 is 1 here. x2 is 2, so it's very simple. Okay. And that gives you 1.75. Is that clear why we have this one? Okay. I'm sorry, I just a little bit repetitive, but just make sure everyone is right. Okay. And for those QFN, then you can take a rest. Okay. So what you have is n plus 1 is 7. 7 times 3 is 21, right? 21/4, right? Like this, right? And I think everyone should know is 5.25, right? Because it's 5th quarter, right? Make sure I'm doing it right, because when you teach, sometimes you make a mistake. Okay. Then 5.25 is what? You start from the 5th and you go a quarter between 5 and 6, right? So it's 5 plus 0.25, 6 minus 5, which is 5.25. Okay. So probably you can tell me what's IQR, right? With easy now we have IQR, we just Q3 minus Q1 is 5.25 minus 1.75, right? And that 0.5 and then right, should be right. Right. So that would be the answer. So I apologize for my handwriting because I usually don't write anything. So I just type. So this only occasion I write things. So probably same. I mean, probably you two are different because you use the Apple pencil to do things, but I never use it. I mean, yeah. But anyway, is that okay? Here you see a lot of calculation, but just to remind you that you never use it because the computer gives you anyway, right? Try to walk you through because you want to understand what the formula is, right? Actually, you should do this when you try to first learn stat formula, right? Because then you know what's going on, but you never use it anyway in the future. Just walk you through the example, and this is the case, okay? I mean, unless maybe assignment or test I ask you, but otherwise, you never use it again, right? And later you learn a lot of black box in statistics, and you will never actually do any calculation, right? But you still try to understand the example for a simple case, how things work out, okay? But okay, any question? Okay, so we spend a little bit time here, but I think it's important to know what's going on here, okay? And this box plot is usually what we do when we try to present our data, actually compare, right? Because here you can see example 1, we have 5 data, right? So this, the lower line is the minimum, right? This is the maximum here, right? The mean, the max, okay? And this is the median, which is Q2. And this line is Q1, and this is Q3, okay? And probably other section, some people ask, what is use of this line, this line, this line, this line, this line, this line here, okay? These lines are useless, okay? Why we have this line? Because that's to make you easier to know which is which line, right? Because otherwise he can have 5 lines and you don't know which one is which, okay? Just for decoration, okay? That's basically 5 vertical line, okay? The horizontal line just to tell you what is what, okay? But here you can easily read from the data, from the graph, right? Maybe I use other color here. This is the range, right? And this is IQR, okay? So it's easy to, you can easily see that example 1 or example 2 has a much more spread than 1, right? No matter you look at the IQR of the range, okay? So this the box plot will be very useful when you try to say, tell your boss 2 is more spread than 1. Okay. I know it's time to have a break. But let me do this one quickly before break. We'll come back, but because this is so important, it's good to have a break with you. So bear with me 1 or 2 minutes. I'll give you 15 minutes break for full, so don't worry about that. So you don't lose any time. Just let's slightly move a little bit. So variance, because why we don't talk about it before break? Because after this we have 3 concepts: standard deviation, coefficient variation, that's rely on variance. And this is the single most important measure beside mean in our class. Okay, mean and the variance, the thing we'll study throughout the semester. Okay, and variance, the idea is very simple. Okay, because we'll talk about dispersion, how spread data is, and we're talking about how it different from the mean. Okay, so we're talking about variance is measure with reference to the mean. Okay, so we're talking about how the data different from mean. Okay, so the first thing come up with the mind is take a difference between each data point and from the mean, right? And you care about the average distance, right? Not just one. So that's why you average it, sum of it, and divide by n, right? Because you want to compare different data set with different sample size. So you care about the average, right? And the question is why we want to have a square, right? Because the most natural thing is forget about this guy, look at the absolute value, right? For those people who don't know absolute value, absolute just like no matter negative or minus, you take a positive, right? Just like the oath you make when you get married, right? No matter good or bad, you stay there, right? So same idea. No matter negative or positive, you remain positive, right? Same as we get married. I don't know whether anyone will get married, but if you have, then you would make the oath, right? No matter the marriage is negative or positive, you stay positive. Okay, it's absolute value doing. Okay, and why you would be doing a square? Why? The reason, there are two reasons. One is square, although it looks more complicated, it's actually easier in the math. Okay, you do calculus. For those QFN students who do calculus all the time, you know square is easier to handle than absolute value, right? With differentiability, right? And all the stat method use square is easier to handle, and absolute value is more complicated. Okay, and indeed, because now computer is very frequent, it's easy now, right? So that's why computing power is cheap. So now we have machine learning method allow absolute value, but they will be different thing, actually much more complicated. But anyway, square, why we square? It means that it's easier to handle. Okay, and square has a property, which means that the data you're further away, right? It means that you get square, it will get higher weights, right? So that it punish the data which is way further away. Okay, so that's a property of variance. Okay, and this is a good one. Okay, and probably you want to ask this is why this is a measure of the variance here. So consider the following case. Suppose you have the three observation, 4, 5, and 6. Obviously the mean is 5, right? Another data which is 3, 5, and 7, right? Again, the mean is also 5, right? Mean, median, mode the same. Mean, median the same, right? Mode is different. But you can see that the second case has bigger variance, right? Because each data is a distance of 2 compared to the first case distance of 1, right? For the extreme data point. So that would be the measurement, right? You just add every data point square and divide by n. Okay, that's a measure. We'll use it for the rest of our semester. Okay, and let me have a break here. There are a lot of complications behind this, but we'll talk after the break. So we just overuse 6 minutes. So we will be resuming at 11:21 now. Is that then will be 36. Okay, so let's resume at 11:36. In the meantime, I go over the classroom. If you have any questions, just please ask me. So that's a break of 15 minutes. 我要小心啲先得。我揾到款嚟，你知道邊度揾到個方向？係你都明白做緊咩嚟？你咩明乜做緊乜嘢？方向後面嗰啲就前面就知道咗，你就當住啦。後面嗰啲就係要有啲普書嘅多啲方向。你睇啲 example 先做，唔係話知道呢度嘅咁樣做緊就咩打波啊嘛，點打波個波咁樣飛埋嚟，咁樣打，波飛埋嚟咁樣打咁樣，你都係過落去我10次，你個波都係咁打，就咁打。assignment 係一個人做 ，assignment 個得一個人做嘅，個 project 係一個人做，你係兩個，應該兩個啦。嘅 A4 紙兩頁咯，最多兩頁一個人。 兩個人做嘅最多4，唔係最少係最多。唔好搞錯，唔好搞錯。多過2頁人唔會睇我啫，係啦。OK， 唔係我下個禮拜會講我下個 set， 唔緊要，好簡單嘅一個空嘅行為。2版嗰個就，不過如果你想做大啲嘅，熟咗啦，你都熟咗啦，講唔到，係嘛？佢講唔到，最尾嗰先出嚟。跟住全部都寫咗，即係而家係一個快嘅。 So let's get back. So in the break, I noticed some of you have learned all the things we cover in this course, so kind of repetitive. I'm so sorry about that, but anyway, I try to do something a little bit more different, focus on applications, as some of you have said, right? So try to make sure that this course is useful. Even you learn it from different perspective, or you learn some application of those. That might be helpful. So probably one thing you would try to see is, if that's the only formula, why have the second line there, right? And why we have this guy in the second line, right? Why we have this guy, okay? And one reason is what we care about is variance. There's the thing that we have explained is whether each data how it different from the mean, and we cut average of those. Okay, so this is something we care. But the problem is we actually never observe sigma square. That is called a sigma square. Never observe in the real world, right? So what we actually do, whenever we actually do, is we try to obtain data, right? And with the data, try to infer, which is something we will or estimate. We will do it in the second half of the course to guess what's going on in the real world, right? So this guess, okay, if you use the formula directly, the guess will be incorrect, okay? And with the adjust, okay? So that's why we will be dividing the difference between the two is, instead of dividing n, we'll divide n minus 1, okay? Note that the formula is always sigma square, want to measure. But we want to, if you have data, we want to calculate the variance and try to guess what's going on. In the big picture, we use n minus 1, okay? Now you understand what they are, then I try to explain why we have n minus 1 instead of n. Why we divide it by n, okay? The reason the exact reason we would say is we will talk about in the fifth topic with estimation. But the idea is the following. One, the intuitive reason is the compare to this case, we have multiplied by n over n minus 1, which is bigger than 1, right? So what it means is we have to make it bigger. They ask why we have to measure to make it bigger. The reason is that, remember what we're going to do is try to measure the variance in the whole thing, right? But we only pick something from the population, right? Pick something from what we want to study. We call sampling, right? Take from studies. And then we try to use this, calculate the variance, try to guess what's going on in the big picture. The problem is you try to get something from that one, the variance tend to be smaller. You can imagine, right? Because you try to get things, can be a lot of data, right? And then you try to get some small part, then it gets things smaller, right? And of course, one of the main reason is, if you won't go to one of the technical, is, which actually we will load later, is because we have to estimate this X bar. If this X bar is, you know mu, which is then you don't have this problem. But we have to estimate this and estimate again twice, so you have degree of freedom less. But I don't want to go to the technical because we will be learning why in the fifth topic. But just intuitively saying that if you use this formula directly, there's a problem. We cannot use this to directly. We have to use another formula to guess. Okay, just the same simple thing, right? say, if you want to, you meet a girl, a boy the same, right? Suppose I meet a girl, okay? I like her, I mean, she looks beautiful, then what are you going to do? Okay? What are you going to do? Boys, anything? So suppose you see a beautiful girl there. I mean, if a girl, you see a beautiful boy here, a handsome boy here, so what are you going to do? Will you go there to say, hey, very beautiful, beauty? Doesn't work, right? You cannot go in this way, right? You got rejected because you look like a weirdo, right? Doesn't work, right? So what are you going to do, right? Try to send flowers, send a lot of gifts until things goes on well, then you do, right? So the same idea here. Something you cannot go directly, right? Go directly doesn't work, right? Right? You can't say it out, right? You never say it out, right? For those of you in the relationship, right? Probably you would just say, oh, you don't look like, will you be my boyfriend or girlfriend? It doesn't work, right? You would be together for a while, and then when things goes on well, then you just ask. Or you shouldn't ask, right? That should be something comes naturally, right? You can't go directly, right? Same here, right? You can't go directly and use the same formula to get what we want. You have to go indirectly. Okay, you have to, if you do this, have to be right. Right? So that's the idea. Okay? Is that clear? So you cannot go directly. Have to go indirectly. I hope this stick into your mind. Actually, we will have the same thing for the rest of the other measure as well. Kurtosis and skewness, we can't go directly. You have to go indirectly. Okay? So later you will see next class we'll talk about this is if you look at the Excel, this is called the variance dot P, and this is called variance dot S. This is the sample, the population. And then you will see why we have this is because I have said already, right? And you can imagine that when N is large, doesn't really matter, right? When the large sample doesn't really matter, right? And imagine that, right? The direct approach, right? You talk to a beautiful girl, woman, right? And a boy or girl, right? And direct approach will work if you're extremely handsome or extremely beautiful. Approach then will work, right? Same idea. N is very large, it works, right? If you're very rich, very beautiful, very handsome, right? Very attractive, you approach the other girl, then you will work, right? Usually, right? But that's the idea here. Where N is large, there's no problem because N over N minus 1 is the same thing. The idea is like the same. The sample size is very large, right? Basically collect everything from the population. No, that doesn't really matter. Okay, so this what we call the small sample adjustment. We don't need it when the sample size is small. Okay, so very quickly we will go to the example. This example that trying to show you how you can calculate from scratch. But as I said, this thing Excel button done. Okay, but I just try to show you how actually operationalize this and how to read the formula. Okay, and everyone should not feel difficult because we go step by step. So the 4 data here, so 5 data point here, and this is the way we do Excel. Okay, I put in table form because this is the way that we will actually work on Excel, and then we will show you how we work on it, right? And this average, right? If you look at Excel later, we will see we will not use mean because Excel only know average. Okay, average is the mean in the data. Okay, and the third column is just subtraction, right? From the first to the second, right? 1 minus 3, and so on and so forth. And the next one is square of the last column is the square of the previous column. Okay, so I guess 等比因数, right? And now we can calculate the population variance and the sample one, right? Population one, you just add them all up, divided by how many of them, which is 2, because add them up is 10. 10 over 5 is 2, right? And if this is sample version, minus 1 is 2.5. So as I said, the sample is larger, and that will be a better measure if this is the data you collect. Okay, so always, I mean, without maybe a few exceptions, you always use the sample one. Okay, when you do calculation, but do note that sample is trying to measure the population one. Okay, It's not this. It's not. We are not trying to measure the M-1 thing. We're trying to guess what is going on in the big picture. Is over n. It's the population one. But in order to do that, to do the calculation, is M-1. So this is the part that sometimes you feel tricky. But in the fifth topic, we're into estimation. We'll explain why that makes sense. That's a better estimate, right? Just like I think there's a better way to think is like basketball. Although I do very badly, but basketball, how you shoot, right? I think it's like if you try to aim for the ring, exactly the middle of the ring, then it doesn't work, right? They'll tell you, I mean, I'm bad at basketball, but those people who good at this sport can tell me whether I'm right or wrong. But right, there's a basketball thing, right? If you try to hit here, usually it doesn't work very well. Where you should aim for? Okay, maybe we have athletes and tell me. Can you tell me where you should aim for? Where? Yeah, you aim for this one. Oh, then you're a very good shooter. So usually, I mean, the people would tell me aim for the corners, right? You aim for the corners or aim for here, then you can bounce back, right? It's like this is better, right? Unless you are like coolie, then can do it, right? But usually, unless you're very good, then you aim for bounce back, right? That's easier to do it, right? Same idea here, right? That's a better estimate. Okay, but anyway, forget about analog. I mean, we will show you what exactly why do this way is better. Okay, in the fifth topic, fourth or fifth, maybe fifth, should be fifth, yeah. So now you understand the variance, then you would understand how to do the standard deviation, because one drawback, although variance is very useful, we usually use the standard deviation instead of variance. The reason is the variance takes square. That means that every unit will be square. Okay, and for say when you measure the length, is cm square become cm square, right? It become a little bit weird way to say. So every time we will just take a square root, okay, of the standard deviation, okay. And we again have sample counterpart, okay. Is for this one. Later you learn the yeah, I think Excel will also have the same with the same. I think STDDX. Am I right? Let me SD. I mean DEV. I think is DEV. STDDEV. Let me don't guess. Let me refer to the slide quickly. STDEVP, yeah, STDEV. So so will be the for this one will be STDEV dot P. This will be STDEV dot S, standard deviation P and standard deviation S, population and S. And I remind you that you'll be using the S for most of your cases. Okay, unless you're big data, probably you can use P. There's no problem because N is super large, so make no difference anyway. Is that clear? Okay. And later you will learn why the standard deviation is important. Because what we call the empirical golden rule, which essentially said, unless the data is very crazy, most of the time your data must be within 3 standard deviation from the mean. Okay, and that is the reason, one of the reasons why you can see the government said it's a 100 years event, right? It's beyond 3 SD than the things you would doesn't expect to happen. Okay, and that is maybe out beyond 3 to 4 or 5 SD, right? I think that is what they claim, right? So that is the idea why you never prepare for something is like more than 5 or 6 SD, right? But things happen anyway. Okay, So that's the idea. So the last one we want to cover is called the CV. It's also very commonly observed. It's very simple. It's just the SD divided by the mean. Okay. What's the good point about that is it become uniqueness. Okay. No matter how you measure the thing, right? Because standard deviation still have a unit of measurement. But now this one is divided by mean, there's no unit of measurement. Why we want to do that? Right? Because the variance then in that case will be independent of whether you measure the length by inch or cm or meter, whatever. Right? And it doesn't matter, suppose you measure the profit, doesn't matter whether you measure in US dollar, Hong Kong dollar, renminbi, or Japanese yen. Right? So it doesn't really matter. And why it matters? Because when you have CV, then you're able yourself to compare across different data set. Right? Your different data set, different mean, then you can compare. For example, why this case is, I look at the every year. I mean, I don't have midterm in this class, but imagine I have midterm in this class and a final in this class. What I expect is it's very likely that midterm has lower variance than the final, right? And for two reasons. One is midterm has less content than the final, right? Final is cumulative. Right? And final is more important, right? Final probably may have 100 points and midterm is 50, right? So by construction, right, you would expect final will have higher variance, right? And the other thing is final have higher variance, like because it's asking more stuff, right? And you can easily see if you do well, then you can do well, do badly, you can do badly, right? Then how can you distinguish these two? Is look at you divided by its mean, right? Because you can imagine that final will have higher mean, right? Because then probably you have higher variance. So that's why when you try to compare data set, you will try to normalize it divided by the mean, right? So that's closely related to the idea of the Z-score, which we'll cover probably later, or not probably in the slide, but in the textbook as well, right? The Z-score, right? That's compare, right? That's how you. Those of you who do study in Hong Kong, they know the DSE thing, right? Then how you do is like each subject you will be normalized is telling you A, B, C, or D, right? Because different subjects and different test paper have different difficulties, right? So you are looking at how you compare to the mean, right? And if you do very well compared to the mean, you get A, and B and C and D and E, right? So on and so forth, right? So for this to be comparable, have to be normalized by the mean. Is that clear? So let's quickly go to example because I think it's too easy. It's with 5 data point, right? And the mean is 3, okay? And the population versus 2, and the sample one is 2.5. So that's to remind you that we always use the sample, okay, in your application. But I just keep the population one here to let you know what's going on. Okay, we never the same IQR. We always use method 3, not 1 and 2. I keep here because you need to know that difference. Okay. In this case, right, the SD is very simple. SD are just taking square root of their own variance version, right? Take square root of 2, give you this number. Take square root of 2.5, you get this number, right? And just to remind you, if you Excel later, take square root is the function is SQRT. Okay, this function gives you the square root. Okay, and the population CV will be this one. Okay, but again, you can of course do the stdev.p and stdev.s will be fine. Okay, we'll go over the Excel in the next class, but this is the what we have. We're working from scratch. Okay, of course, we'll also show you how you calculate from scratch in Excel as well. Okay, is there any question? No, because I try to be quick because this is something very simple. Now, the remaining time I'll talk about kurtosis and skewness, and that will conclude our day. Okay, we basically cover everything about how to present data. Okay, we finished the mean, median, and mode, which is central tendency. We talk about range, interquartile range, variance, standard deviation, coefficient of variation for the range or spread. Okay, and talk about shape. Okay, Just to remind you again why I care about the shape. First, is the shape can tell us whether your data is good, because we know from the historical data, we can have this measure, and you measure again, then you know whether data is good or bad. Okay. And as again, if your data looks very weird in the shape, then you have to be very careful when you further do analysis, right? Because descriptive statistics, not only you want to show it to your boss how the data looks like, and also you want to have idea what kind of tools you want to do further analysis. Okay. And the skewness and kurtosis can tell you actually whether the data have some extreme value or there's some problem. Okay. The first one is skewness. Okay. The skewness by itself looks crazy, the formula, but if you just bear with me for a few minutes, then you will make sense. Okay. The first one is skewness is look at the numerator. Okay. If you still have formula in your mind about the variance, okay, the variance just have the square here. Okay. This is the formula for variance, right? It's just square. Now we are away from variance. We have 3. What does that mean? Okay. It means one thing is for square, it's always positive, right? For cubic, it can be negative, positive, right? If you start with negative, it will be negative. It's positive, it's positive. What does that mean? Okay. It means that if there are more of the data higher than the mean, the skew will be positive, right? If your data is below the mean, then it will be negative, right? So the measure, if it's 0, it will be symmetric, right? That's the idea. The next one is look at the denominator. Okay. The denominator is divided by cubic of the standard deviation, right? So that is the always positive number. So it's just like scaling. Just like coefficient of variation, we divide it by the mean, right? So probably the question you want to ask in your head is, okay, why we do this, not divided by this one, right? Fine, you can do that. The reason why I do this is because this is what the Excel is doing. Okay, Excel, this one actually got skew. I think got skew P. Skew P. Okay, and as I said, there are many type of measure, right? You can divide it by the mean is other measure, but we just use the Excel one because it's someone people report. Okay, and there's nice property for this one, but we don't have time to go over why this is nice, but just pick up the one measure. Okay. And this measure, as I said, if it's positive, that means positive skew. Negative means negative skew, right? And 0 means symmetric. Okay. And to give you idea what is positive skew or right skew data, is the income data, right? Because you have a lot of people, you have some people that have super rich, right? Suppose you get the income data in US, you got the Elon Musk or Bill Gates, then they will skew the data a lot, right? And same is Hong Kong, right? And Hong Kong is the most heavily skewed, right? Because look at the data, right? Where in this world have the most billionaire or millionaire is Hong Kong, right? So it's in terms of density, right? So that would be Hong Kong is most rightly skewed in this world, right? And what is lab skew data? Okay, lab skew data is the exam data, exam score in our class. Why? Because CHK is one of the best school in Hong Kong, and B school is one of the best school in the CHK, right? And you guys is one of the best in Hong Kong, right? So that's why it's skewed, right? If you look at Hong Kong data, will be symmetric, right? But you guys are best of best, then you will be very highly skewed. Okay, because all of them is below the mean, probably will not be there. right? So that means that if you go further and further, go to the grad school, then it will be even more skewed, right? So that's the idea, right? So is that clear? Okay. So that would be the data. And if your data is close to the 0, then your data will be fine. You don't have any problem. If data is highly skewed, then the problem may be your analysis can be some issue. Because later when we try to do things, we try to think your data is symmetric, right? Then things will be easier. But now the data is skewed, and a lot of things we have to think about can be a little bit different. Okay, but we just assume in our analysis, with the data do not have much problem. The skew is close to 0, not too much, not much different from that. Okay, and as I have said, everything try to measure in statistics, you can't go directly. Okay, you have to approach indirectly, right? So that is the reason why you have the indirect measurement. It's the thing that you have to adjust by this guy. Okay, that means that if you actually doing any calculation for skewness in your data, you always have to do this. Okay, this thing looks crazy, but this is what we do. And don't worry, actually when you apply in the practice, this is actually in Excel, it's just called skew. Okay, there's nothing difficult here, just skew, and then you can figure that out. Okay, and I will try to show you how you do an example. Okay, the skew. Okay, well, quickly. Okay, this example here. Okay, I'm not going to one by one because we already covered this in the last time when we do variance, right? So the skewness is just raise this column to the 3 times. Okay, and turn out that you will, as we expect, sum of this skew will be 0, right? Because 1, 2, 3, 4, 5 is symmetric. As you expect, no matter what you calculate, population or sample, is all 0. Okay, I'm not going to one by one how this number map to each of those. You should be able to plug it in by yourself. Okay, if you are unable to do it, ask me later. Okay, so I will do more detail for the next one. Okay. So skew 0 is like this. Okay, I'll do a little bit more detail for this one. Okay, so again, you would be looking at the data is like this. Okay, this is the mean, the second column mean. Then this is subtract from mean. This is square from this column. This is cubic from the difference column. Okay, and from this one, you can calculate the sample variance. Do note that -1 because the sample version, and take a square root, gives you the S. Okay, so now we want to know this the population skewness, which is very simple, which is the last column number, right, and divided by 5, which is n, right? This is this, right? This is the formula here, and the denominator, right, will be 50 here, right, divided by the n is here, raised to the 3 to the power 2, right? So give you the answer. Okay, and the sample one will be just, this is n, this is n minus 1, this is n minus 2, and this 180 is here, and this is coming from this guy, right? So that gives you the sample version, and you can see the sample one is much larger than the population, and you can see the skew is positive, as you expect. Why? Because 1, 2, 3, 4, the mean is actually 4, right? The mean is 4, and you have 10 there, right? So it's like 10 is like skew the whole thing. Okay, but do remind you that, I mean, You never actually work out this, right? You would just go to the Excel and just plug in the number and just skew, and then you're done. I'm showing you that because I want to show you how this formula works. Okay? You never actually work this thing out in the practice, right? Just basically in Excel, right? Just skew, right? 1, 2, 4, and then this gives you the answer directly, right? But I just show you this is how you can do calculation. Okay? So this will be positive skew, right? And in general, only true in general, when you have skew data, the mean will be bigger than median. Okay? It's only true in general. Okay? Sometimes it may not be true, but in general, when you say positive skew, mean is bigger than median. Okay? Not always true. But in general, you can think about it in this way. Okay? Negative skew, the median is bigger than mean, right? So that would be the case. Okay? In general, but not always. As I mentioned, why you care about skewness, for those from quantitative finance or interest in finance, is because of the asset pricing right now. These days, the latest research show that skewness actually carry premium. Okay, in old days, for stock market, the way we analyze is care about mean and variance, right? You want to buy the stock that have higher mean and low variance, right? But what about skewness? Is the stock have positive skew? We pay premium for that. From empirics, actually we do, right? And you try to buy IPOs, you try to buy the stock that we call the monster stock, right? Or the crazy stock, right? Say Tesla, GME, those kind of stock, right? You want to pay a lot of premium for that, okay? Because you expect highly skewed. It's like buy a lottery ticket, right? People buy lottery ticket because the high skewness, small probability that you will become super rich, right? Why people go to Macau, right? That's the idea, okay? And skewness is important because you should take them into consideration, okay? Is that okay? Lastly, we have kurtosis. And kurtosis, if you understand skewness, kurtosis is nothing new because you look at the formula, you just change this from 3 to 4. That's kurtosis. Very simple, right? There's nothing new here. And you want to ask what this measure is doing, right? This measure is asking one thing very simple, how extreme value they are, the extreme, okay? And raised to the power 4 means the extreme value of raised to the power 4 is very large, super large, right? And what's the benchmark, right? Skewness, the benchmark is 0, positive or negative, right? For kurtosis, the benchmark is 3, okay? Why 3? 3 is coming from, you have the bell curve. Everyone know bell curve, right? Bell curve is always 3. Normal is 3. So if more than 3 or less than 3 is something we care. If more than 3, it's very fat tail, we call. If less than 3, we call thin tail. So that's why in practice, we don't care about kurtosis by itself. We solely call excess kurtosis, -3, okay? More than 3, we will jump up. Okay, the tail is very thick. We have to be very careful. Less than 3, we don't really care too much. Thin tail is usually not a problem. Or the problem is thick tail, right? Because thick tail means a lot of data has an issue. You have to be very careful. Okay? And thin tail and thick tail, there's I think Greek letter, mesokurtic, elliptokurtic, and platokurtic. I'm not care, but I just put it there in case you see it, you know what's going on. Okay? So graphically, it's like this. The blue one is the bell curve, is the normal curve, is the thing that you would use it all the time in the second half of our course. We always use normal, okay? But the problem is sometimes a thick curve and is a red one. Red is the thing with a thick tail, okay? And thick tail will be issue. The excess kurtosis is more than 0, okay? And the thin tail with the golden one, okay? So probably you want to ask, what is the formula in Excel for this one? Excel has no formula for this guy, okay? Because this guy, we never calculate this guy. We calculate the guy which is this guy, okay? Monster, okay? I'm not going to ask you for this monster, okay? But this monster, the formula is very simple. Kurt. That's it. Okay, in Excel, we'll talk the next class. It's called Kurt. Kurt, and then we'll give you the formula. And this one actually gives you the excess kurtosis. You don't need to minus 3. Okay? Give you this, and you see whether it's more than 0 or less than 0. More than 0, fat tail, be careful. Less than 0, you're fine. Okay, 0, of course, is the best, right? So that is the thing we care. Okay? So remaining 2 minutes, I just want to give the idea the kurtosis, okay? I'm not going to the formula because that is too crazy, okay? I mean, but I just trying to put it there in case you want to go look and see, okay? And if you're this kind of data 1, 2, 3, 4, 5, you can do the same thing. You calculate the last column raised to the power 4, right? And then you can calculate kurtosis, right? And excess kurtosis, right? And you can see from this sample, the excess kurtosis and the population one and the sample one is very similar. Not too much issue here, right? And it's negative. Actually, it means that the data is very condensed at the center. It's not fat tail. It's a thin tail. So we don't have a much problem here, okay? Let me contrast it in another example. In this guy, 1, 2, 3, 4, 15. You can imagine the tail is very fat, right? That is, you can see the population version is not too large. It's slightly more than 0, right? But in fact, if you do the sample version, which is you will do in Excel, will give you a much larger number. It's 4. So it's super large. Okay? So that's the reason why you cannot use the direct formula to calculate this, because you can imagine 1, 2, 3, 4, 15. It should be a fat tail, right? So that's why you want to estimate the excess kurtosis, you should be doing this. Okay? You'll be using Kurt in Excel to do it. Okay, don't worry. The formula, although is crazy, but I think you can just pick and choose and see what the formula actually doing. But you will be using Excel anyway. Okay. So I will see you on Friday. I think time is 1 minute. But any question? Any question? -3?
But then for the sample one, why do we have to adjust for 3 as well?
Oh, this is measure sample excess kurtosis. So you can use directly.
I mean, like, trying to have an adjustment factor is to adjust the sample to more fit.
Yeah, because the thing is, like as I told you, you cannot actually use this to measure. Oh yeah. Why you okay? Because of the way you -3 is not appropriate. So you have to -3 adjust in this way. So just like this is Excel outcome. So if the -3 is not what Excel tells you. So the Excel formula, and this is the best formula that you would try to do excess kurtosis. No, just this. You just adjust like this. This is the Excel tells you. So adjust in this is the better. There's some issue. You just -3. So that's I mean, technically just unbiased estimator. You have to do in this way. So of course there are many versions. This is the version Excel use I give you.
Like 3 is sort of the normal distribution, right? It's perfect.
Yeah, but your -3 is like, is it okay? For example, your -3 is a little bit is still overestimate. So you have to do it this way. So this is the best way. Okay, it's out of our scope to talk about why.